Yeah, we're continuing with a little bit of review here. So these are reviews, questions of Chapter 1, AP type questions. So if P of X is continuous, the word continuous is usually a clue that you are talking about the intermediate value theorem or a couple of the other what are called existence theorems, which we'll talk about later. But so a function is continuous on the interval from 1 to 3. And we know that the y value at 1 is less than or equal to k, which is less than or equal to the y value at 3. And we know that c is in that closed interval. So what must be true? All right. So sometimes on the test you can, when they like to give kind of more conceptual questions where they're not giving you an actual function that you can plug in. So we have 1 and 3 down here, and we have P of 3 somewhere. I'm going to put it up there. Oh yeah, it's above, so alright. And we have that. And they tell us we have a K up here, and we have a C in here somewhere. Doesn't matter. And so at 1, that's that, and this is here. Now they tell us that it's continuous between those points right there. So if it's continuous, that means that I have to draw from here to here and I can't lift the pen up. So it could be a straight line, it could be a line segment, but it could go way up here, could come down here, maybe go back like that. So that's a possibility. We really don't know what it looks like. But the point is, like I said, another option would be could go just straight like that. So those are just two possibilities, the red one or the purple one. But the point is that somewhere on the graph it's going to be equal to that. So I didn't really put it in a good spot. So K would be right here, which means if K was right there, that should have been C and K if it was a line segment. If it was this red function, then C would be over here. Yeah, and it never gets back to there again. So really, this should be the red C, and this one should be a purple C, if we want that to match with the picture there. So what we're saying is that P of C has to equal K, because P of X is continuous. They told us that right here. P of X is continuous because P of X is continuous by the intermediate value theorem. And you don't have to write the whole thing out. Okay. So these are some specific things that have definitely shown up on a few tests. So identify, look at this. So you were doing this the last couple years. This is AP Calculus, and you get to just talk about some vertical asymptotes here. Now, the tricky part, and you should have probably seen this in pre-calculus, but so what we want to do here, rational expression, probably factor, maybe cancel. So X and X, that's negative. That means the signs need to be opposite. That is, so I need a positive and a negative. I need to look at factors of 4 that add up to, or subtract in this case, to give 3. That's going to be 4 and 1. So I need 4 here and 1 here. Now the denominator, that's going to be X, and that's negative also. So again, it's plus and minus. This is positive, so that's going to be 2, and that's going to be 1. Now, a common mistake is some students are going to rush into this, and they're going to say, oh, negative 2 and 1. Negative 2 and 1. Bam, the answer is A. Well, that's going to be wrong, okay? Because really, we have a removable discontinuity. Removable discontinuity. So, the asymptote is actually just x equals negative 2. So that's the answer there. Now here they're throwing some y's in there to try to confuse you. Here they throw in this, but that's not the case. So we have 3 different questions here. Question 1 is vertical asymptotes. And when I mean we don't have 3 different questions here. There are 3 different ways that this question can be asked. One will be they will ask you for the removable discontinuities, in which case the answer would be B. What did I just say? I think I just said that back. I was thinking of the next thing I was going to say. Number 1, they ask you for the vertical asymptotes. That's going to be this. Number 2, they ask you for the removable discontinuity. That would be, the answer would be C. That's the second type of question that I ask about that sometimes, and they do. And the third question would be, where is it discontinuous? Or where are the discontinuities? Discontinuities. Okay. So that would be both of those, because a vertical asymptote is an infinite discontinuity, or infinite discontinuity, and a removable discontinuity. Those are two types. So in that case, the answer would be A. So there's sometimes I ask you, in a free response test, I ask you for a couple of those things, or maybe all three. So that's an important question to study, come back to, and make sure that you understand what happened there. Okay, find the limit of this. Well, this is really in Chapter 5, and it's a calculator question. This is not anything we would have memorized. So I'm going to go ahead and do it anyway, just because it's here. So I could go to y equals, and we could type that in. Now, e to the x is right here, little green button. Notice how I put a times there, so you can kind of maybe see a little dot, x times parentheses, and then the green, e to the x, and then it just puts e to a parenthesis. So then you have to type x, and then plus 1 over x, close a parenthesis, and that's what it looks like. I changed my window because we're talking about 0, so I wanted to be close to 0. So I changed my window to -2 to 2 on x and y. So when you graph that, is that coming anytime soon? It's a little bit awkward. Okay, so I noticed there's no check mark there. I don't know if I accidentally hit that or not, but if you look up there, F4 is a check mark. So now there's a check mark by it, so I'm going to hit enter, and then I'm going to graph that again. So there's the graph, and the question is, what's the limit as x approaches 0? So as x approaches 0 on both sides here, that's equal to 1. You can go to the table and kind of see what's going on there. I switched my table set back to automatic, and so you can see it's undefined at 1. It's hard to see that those are approaching 1 on each side. I could make those numbers smaller and get closer to it, but you can tell from the graph. So that's not a big deal right now, but I just figured I would show it anyway. So that's going to be 1. All right, we saw one like this. Again, these are all review questions. The chapter's over, so we're going to, hopefully you can pause this right now and do this problem. If you can't, we need to do a better job on our assignments and our notes. So remember, when you do an assignment, you should not be, anything that's highlighted, you should not be skipping those problems on the assignments. These two questions are very similar. Okay, so the question is the function continuous at 1? So you need to, and then why or why not? So for a function to be continuous, it has to meet 3 criteria. So we talked about those. So the first one is that it has to exist at the point. So f of 1. So f of 1, when x equals 1, is 1 squared. So that's 1. So that's true. So that's the first thing we need for continuity. All right, number 2, the limit has to exist. So what that means is the limit as x approaches 1 from the left, and if we're approaching 1 from the left, we're using this piece of the function, has to equal the limit as x approaches 1 from the right of this. So that's going to be 2 minus x. Okay, so if you plug this in here, you're going to get 1. And if you plug 1 in there, 2 minus 1 is 1. And those are equal, so the limit exists. Okay, the limit exists. So that's step 2. So that worked. So that's good. Then step 3. Step 3 is that the limit as x approaches 1 of the function has to equal f of 1. And that was 1 and that was 1. So that's true. So that is y. Yes. So the answer is yes. And all of that is y. Okay, it seems like a lot, but it's not that. It's really not that bad. Okay, what value of k will make this function continuous? So for this function to be continuous, these need to be equal to each other at that boundary point. So we need to plug in pi in for x here, and we need to plug in pi in for x there. So we're going to have the sine of 2 pi, and that's going to equal 2 pi plus k. And we're solving for k. So the sine of 2 pi, hopefully you can think about that. It's going to be 0, and 2 pi plus k. You're going to subtract 2 pi from both sides and do that. Okay. A little bit until I get a better system with the camera. I'm having some issues. That's why you see multiple clips on these things. I'm going to maybe go a little bit faster sometimes. So just pause it. If it's going too fast for you, pause it and work on that. Okay. So a lot of review here of chapter 1. So all these review questions didn't necessarily need to be done at the same time. You could do those on a different day. Like I said, this week was a little bit crowded as far as lessons go. A lot crowded, actually. Okay. So this might be an example. Then this is not off an actual AP test. This is a review company tried to make a question like an AP question, so it's not that big of a deal. So they'll tell you whether a calculator can be used or not. A calculator wouldn't have been helpful here anyway. So what we want to look at here is f of g of x continuous at 0? Explain. So remember, for it to be continuous, we have to do those 3 things. So number 1, we have to say, does it exist? So f of g of 0, what do we have there? So g of 0 is 2. G of 0 is 2. So that's going to be f of 2. So then we come over here, f of 2 is negative 1. So it exists. So that's the first check. Yes, that is something. Okay, then we have number 2. So number 2 is going to be the limit as x approaches 0 from the left of f of g of x, and we need that to be equal to the limit as x approaches 0 from the right of f of g of x. This is more cumbersome than we're going to have to worry about sometimes. So if you're feeling a little bit bogged down by this, it's not super important here. Okay, so to test that out, f of g of 0 from the left. So you're going to go g of x is here from the left of 0. So this is different than what we did over there. That was asking us specifically what g of 0 was. G of 0 is 2. The limit of g of, as we approach, as x approaches 0, as x approaches 0 of g, the limit on the left side is 1. So that's actually 1. So we have f of 1. F of 1 is negative 1. Okay? Now here, from the right, that equals 2. What's the limit? And this was in our notes. It was one line in our notes, and it gave you a page number in the book. But if you plug in, remember, you're supposed to take the limit of that inner function. So the limit of 0 of g as we approach 0 is 2. If we're on g and x is going towards 0, then this is going towards 2. So that's f of 2, and we already looked at f of 2 as negative 1. So those equal each other, so the limit exists. All right? And finally, for the third step, f of g of 0 has to equal the limit. And we can see the limit was -1 and the function was equal to -1. So -1 equals -1. Put that here, -1 equals -1. So yes, it's continuous. Okay? Now, if we do it in reverse, g of f of x. So f of, okay, so g of f of 0. So, like I said, this is if you're bogged down right now and you're not feeling it, you don't need to worry about this too much. But if you want to get the whole experience, hang in there with us a little bit longer. This is the last page. We're almost done. So f of 0 is 0. F of 0 is 0, so that's going to be g of 0. G of 0 is 2. Okay, step 2. We have the limit as x approaches 0 from the left of g of f of x. We need to compare that to the limit as x approaches 0 to the right of g of f of x. Okay, so f from the left is 0. So f, so that's what you're taking the limit of according to the rule on the earlier lesson. So that's 0. So that's going to give us g of 0, which is 2. G of 0 is 2. Now, from the right, it's -1. The limit of f of x as x approaches 0 from the right is -1. And g of -1 is actually 0. Those do not equal each other, so that's bad. So no, it's not continuous. Okay? All right. Next question here. What is the limit of this? So the rule basically said that you take the limit of the inner function. So it's the limit as x approaches 1 of g of x. Okay? So as we approach 1, as g of x, x approaches 1, y approaches 1. Right there. So that is equal to f of 1, and f of 1 is -1. So that's the answer there. All right. Now, if h of x equals this piecewise function, what is k so that it's continuous at 0? So for that to happen, the boundary point has to be equal. So that's at 0 here. So we have the limit as x approaches 0 from the left, and we would be plugging in 0 from the left. So I'm going to do that like this: 0 from the left, 0 from the left. So on f, if we go back up here, 0 from the left is 0. And g, 0 from the left, is 1. So 0 plus 1. Now, on this side, we have the limit as x approaches 0 from the right. That's going to be k times g of 0 from the right times g f of 0 from the right. Just plugging those in here. So this is going to be 1, and we need it to be equal to k. You can't see that. Okay. So g of 0 from the right was 2. We talked about that before. So that's going to be times 2, and 0 f as x approaches 0 from the right is -1. So that's going to be -2k divided by -2. So k equals -1/2. All right. And one last question, and then we're done. You can see a little bit of statistics on the multiple choice test. In 2019, the world average was 53% correct. Arborview High School was 65% correct. So you can see we've practiced a lot of multiple choice questions already in our notes, and that's going to help us for the real AP test. All right, so last thing here, let's wrap this up. The limit of g of x equals 1/2 as x approaches b. So if we come back up here, I'm going to rewrite that up here so we can see it. So the question was, part E, was the limit as x approaches b of g of x equals 1/2. So what we want to do is look across here. That's x equals, that's the y value is 1/2. So here's one, here's another one, and here's another one. Now you have to be careful, like if that would have happened at 1, I would like that better maybe if that was 1, because if we were looking at 1, this is not an answer, because the limit does not equal 1 here. I might change that for next year actually and say that that's 1. So the answer here would be 3. It happens 3 times. Okay. And that's it for today, or for this lesson. Remember, the orange is just for me. Next year I'm going to change that to a 1. So, all right, please work.